Hey there, I'm Lily Dabbs, and this is Lab 5 for Geography 2011. In the first part of the lab, we focused on LiDAR data, here, and that stands for light detection and ranging. Basically, it is an optical remote sensing technique that uses lasers to collect samples of the surface to then measure accurate X, Y, and Z coordinates of the surface materials. It's collected by air using airplanes and even drones. In Lab 4, we use point data, where we manually enter the coordinates of different places on campus. And then each of those sets of coordinates became a point in our data set. Now, this didn't give us really any information on the structures themselves besides their location. LiDAR, on the other hand, uses the light pulses that are shot down continuously to provide 3D information about the surface and the structures on it. And as you can see in this model of downtown Minneapolis, it's incredibly detailed. You can see the river, different greenways, all the buildings. You can even get a basis of where the roads are in relation to sidewalks. Now, to get an accurate measurement of the structures, we actually took a transect using this handy tool of this building down here. And from the side view, we're able to use this measuring tool to get the total height of the building. So excluding the antenna at top, the building is just shy of 50 meters. Now, if you go viewer does not tell us the unit of measure. However, from the metadata, I found that it is units in meters. Now, this building is actually the Guthrie Theater, which you can see here in downtown Minneapolis. And again, just the comparison in detail is really striking. All the different curves. This is a very interesting building. Are all documented here. As you can see, you can walk around for a little bit. You see the overhang and even the antenna, which you can see here. So it just showcases how accurate this data is. While it's still a little bit fuzzy, it gives you a wonderful view of the real life structures. Now, in the second portion of the lab, we looked at DEMs, which are digital elevation models. So here I have different views of this model. So DEMs are representations of geographic surfaces. They're actually layers of pixels, each with an ascribed value, that is a measure or a coordinate. Now, these pixels can be color-coded to give us a view of elevation in the area. So as you can see here, it changes colors as it changes elevations. Might be better to see here so you can follow along the different color changes. And it's still very accurate as far as capturing the crevices and the dips and the valleys on this landscape. And part of the assignment was to input this layer of buildings in the valley, which you can see better from this model here, which is up close. So while both of these techniques offer really amazing technological advancement, LiDAR particularly really impacts future development in GIS and in other fields such as planning or design. It is quick and efficient. It is a swift scan from above that shows you natural barriers, it shows you structures, it even shows you elevation change, which could be very helpful when potentially surveying an area for development. Yes, I think that's about it. Thank you for listening.